So something that was in the class kick on your first lesson was parallel lines. Seeing as we're doing the live stream and things were getting a bit chaotic, didn't get a chance to go over it. So we're just going to quickly do parallel lines. They're really easy, and then we'll get into today's lesson on simultaneous equations, solving them graphically. So first of all, parallel lines. Parallel lines, remember, always go in the same direction, never touch. They have the same slope. If we're putting them on a Cartesian plane like this, you can see their gradient is the same. They just have different y-intercepts. So all you need to know for if two lines are parallel or not is the gradient. So for example, let's try this one. Are these parallel? Let's say y equals 6x minus 2 and y equals 6x plus 20. Now, if we look at this, we just need to remember that in the equation y equals mx plus c, this is the gradient. And so the coefficient of x is 6 here, coefficient of x is 6 here. They're the same, so yep, parallel. A bit harder. Let's say we've got, let's go 3y plus 9 minus 12 equals 0, and y equals 4 plus 3x. Now this is about as hard as it gets, to be honest. We need to know, sorry, that should be 9x. Are these parallel? Do they have the same gradient? Well, I need it to be in this form here, y equals mx plus c. This one already is, kind of. We know it's the coefficient, so the gradient is 3. This one here, though, is going to need some work. So let's add 12 to both sides and take 9x away. So 3y equals 12, because I've added 12 to this side. I'm going to take away 9x, and then I'm going to divide by 3. 12 divided by 3 is 4. Negative 9x divided by 3 is negative 3x. Now that one had 3. This one's got negative 3, so no, they aren't parallel. Those are going to go in different directions and overlap at some point. Now, this actually works quite well, because speaking of overlapping, when I come to solving these simultaneous equations, graphically, what I'm thinking is, where do these lines overlap? Now, simultaneous equations, if we look at these equations here, because these are all equations, y equals 6x minus 2, this has infinite number of answers, and the answers come in pairs. They have an x answer and a y answer. So let's say x was 1, 6 times 1 is 6, minus 2 is 4. So when x is 1, y is 4, and that is one solution for this equation. And there are infinite numbers of solutions, and if we plotted them all, they would form a straight line. When we come to simultaneous equations, what that means is two equations that are true at the same time. And if I do a quick sketch here, let's say we've got red line and blue line. There's only ever one point where they are true at the same time, and that is what we are trying to find by graphing them and looking at where they overlap. We're going to learn some algebraic methods to find them out, but first of all, we'll start with the easier one, which is graphically. Now, I'm just going to pause the video here real quick and grab a Cartesian plane to work with. Alright, so I've got my Cartesian plane. I'll just write that out, and we're ready to have a go. So, simultaneous equations. Let's write some notes real quick. Just make sure you write in the box before I can move it. Finally learned that. which is saving me some time. So, let's say equations, or linear equations. Linear equations with a y and an x have an infinite number of solutions. If two linear equations are true at the same time, we'll say simultaneously, then there is only one possible solution. Alright, so let's get this example. Find the that was awful. Find the simultaneous solution to the two equations let's say y equals, well, what happened there? Y equals x plus 3 and y equals negative 2x. Alright, so I need to plot both of these on this Cartesian plane, and then wherever they intersect is going to be our solution. Now, I'm going to use, just so it's nice and large, every second grid as a number. The neater you are, and I would recommend just searching Cartesian plane blank and printing a couple to save you having to draw it every time. More, probably stuffed up somewhere. Every second one, like so. Okay, first equation, and I'm going to circle it in red and draw it in red, and I'll circle that one in blue and draw it in blue. Alright, x plus 3, so gradient is 1, and y-intercept is 3, so I'm starting at 3, and then every one amount I go across, I also have to go up. I've chosen to go up and across by 2, just so it's a bit larger. And then, I think, let's see if this works, or what it even does. Does it like conform my line to the edge of it? Oh, it does. That's nice. Alright. There we go. And then in blue, well, that's m because it's in front of the x. But we don't have a value here, which just means that it's 0. So it intercepts here, and then every one I go across, so let's do it 1 this time, just 1 across, I go down 1, 2, and that is my new point. I might go again, just so I've got more points to work with. 1 across, 2 down, and there we go. Now let's get this ruler back up. How good is this? Perfect. And there you go. So that is our 2 lines. Now we need to look, where do they intersect, because that's what we're solving for at the moment. And that is this point here, which is 1, 2 up. So the y value is 2. And it's 1 back, so the x value is negative 1. So that's the solution. When both of these are true, x is negative 1 and y is 2. We can try it. Negative 2 times negative 1, well, that's positive 2. Yep, that's true. Y is positive 2. Alright, let's try this one. Negative 1 plus 3 is positive 2. Yep, that works as well. So there you go. Oh, sorry, I've written it a bit off the page at the bottom there. That's how you do it. It's as simple as that. So if you're good at your graphing, you'll be able to draw two graphs and look at where they intersect. But the neater you are, the easier it's going to be. So have a go at the class kick and then the questions. With the class kick, make sure you're pressing the raise your hand button if you're having problems, and I can come along and help. You can also, if you're doing it outside of class hours, raise your hand. I'll still get to it at some point, and I might email you when I do, so you know to go check it. Thanks.